One problem I've been working on for off and on for quite a while is how to handle trigger input into the Xbox adaptive controller. Now, this is an analog input, and I want to be able to have kind of alternate ways of getting into that analog input. Now, a lot of the times there'll be like a foot pedal or something like that, or a small switch that has a potentiometer inside with its spring to spring it back, so it's kind of like a gas pedal on a car. Well, I wanted alternate ways of doing that. For example, I would like to be able to have an arcade size button that would be in effect analog. So the harder you press or the further that you press, you get an analog input from 0 to 1023 or whatever it is. So there is someone did make one, Blue Tip Gaming out of Ohio makes an arcade button that has an analog output in addition to digital, and basically the harder you press or the further you press, the resistance changes like a potentiometer. I haven't gotten one yet. I need to order some because I want to try them out, because it might be a real good solution that I don't have to make something from scratch. But my concern is that, well, I don't get to make something from scratch. I like making my own stuff because I like making custom things. Also, I'm concerned about the amount of throw. I don't know if it has enough throw. I'm looking for something where somebody has like a short amount of throw, maybe an inch or so of throw or less, to get some feedback. Now, one thing I could do is, well, you could use the traditional potentiometer, which normally I have a bunch around, but I don't have one right now. But another option is a slide pot, and this is a slide potentiometer. So if you can imagine a slide potentiometer kind of being bolted to the side of a push button, as the push button moves up and down, you could adjust the slide potentiometer. Well, why not use a Hall effect sensor? Why not use a magnetic sensor? Why not use any of other sensors? Well, part of my design challenge is to have something that requires no electronics, no active electronics. So a potentiometer and wiring is okay because it's a relatively passive component, but I didn't want to have a microcontroller, so I didn't want to have that going on. So that's why I have not pursued like Hall effect, things like that. So anyhow, back to this. The problem with the slide is it's too stiff and the throw is way too long. Even the very short slide potentiometers are just way too long. Well, I went hunting on Mauser and I found this. This is a little tiny slide potentiometer. Like every other potentiometer, it's got its 3 pins, power, ground, and wiper, and it is real short throw. It's 8mm throw, and it's relatively light throw. So like to have a return spring press it back is not going to be a big deal. If I had to put a return spring on this, it would have to be a really strong spring, which means the user would have to push really hard to get it going. So what was this originally used for? This is actually an automotive part. It is for aligning automatically headlights in cars. Now, my car is older and it doesn't have this fancy feature, but I guess some cars have the ability to automatically move their headlights. Boy, I wish that was more common, because then I wouldn't be blinded at night so much. But anyhow, that's what it was originally for. Now, the downside is that this, in this format with only an 8mm throw, is only available in a 4.7 kilo ohm range. Now, the Xbox adaptive controller, without any other electronics, is expecting a 10K potentiometer, something around 10K. But that's not going to stop us, will it? So here is what I did. The first thing, or actually this is about the third thing because I've been iterating through it. But I took this slide potentiometer and I soldered onto it. The wiper, unlike other ones, is on the one side. This is called pin 2. The numbering is very strange. Pin 1 and pin 3 are here. And in order to get it up to 10K, so the slide pot does 4.7. So I soldered in a 2.7 on each side, on the ground side and the power side. And ground and power kind of arbitrary. It depends on what the XBAC is expecting. So if it's going the wrong direction, you need to switch your wires. There's no other polarity other than that. So anyhow, 2.7, 2.7, 4.7 is around 10.5 kilo ohms. That gives me a full range on the XBAC controller. So here you can see I've got some cables. I really hate jumper cables and everything, but it's going off to a TRS jack over to the XBAC. And if I can get this camera to switch over, let's see. Yeah, there we go. Let's see, do I have it plugged in? I'm not sure. I was unplugging a whole bunch of stuff. Let me plug this back in. Oh, unplug, plug. And I think I have to click on this to make it active. Oh, look at that. It's going back and forth. So when I have it in the down position, it's high, and the up position is low, and it's going all the way over. Axis 1, you can see, is kind of floating. This is because I currently have this plugged into a joystick X1 port. So that value is all over the place. So I'm just looking for that X movement. I don't care what's going on with Y right now. So that is working, which is really super great to see. The other reason I don't have this plugged into the triggers is an idiosyncrasy with this gamepad tester that I'm using. It treats the triggers as digital instead of analog, and on the Xbox they're analog. On the Nintendo Switch they're digital, but Xbox is analog. Let's see if I can get this picture back over here. There we go. So what I did then is I went to my ye old SCAD tools, my OpenSCAD, and I started designing my own throttle button that will fit into a arcade size hole. Now I'm using 30 millimeter holes because my users typically need larger buttons. So this is a couple of parts together. There's a bottom, there's this part, this shaft, and then there's the button part itself. And you can see it's creaky and cranky right now, and that's what I'm working through. But goes up and down, and it's spring loaded. There's a spring inside. And the way that this works is this potentiometer is poking into a little hole that's in the shaft of this button. So as you move this button, it's sliding the potentiometer, which is then changing the values. And the bottom of it is screwed in place because it holds a spring inside. And if you're really lucky, I'll take it apart for you so you can see what's inside. And again, I want to point out, once you see all this was done not with those fancy visual 3D modeling tools, but with good old text-based programming CAD, which maybe it slows me down, but I can crank this up pretty quick. So that's my blurb for OpenSCAD. So here we have a part, the square mates with that square. The circle is fit for the spring. Here we have a 20 millimeter spring in here, and this pops out. See, there's that. The button itself pops out, so you can see that's its shaft. Now I did have a round shaft, and then I was playing with a square shaft. I have to find something that has the least amount of resistance, and the 3D printing artifacts are causing it to make the grindy. So, and then in this part, it's got the hole for the slide pot's wiper. It's got a cutout here that's exactly the right size for it, and the holes for assembling all together, because assembly is always a big deal for me. I have to be able to do things quickly, and you put that there, you put that there, you put the spring here, you put that there, you hold it down, you put your 3 screws in, and you're done. So it's pretty quick to put together. So I'll eventually have a nicer top. It'll be either concave or convex. I'm not sure which. And I really need to get rid of that grinding. But I do like the features that, one, it's got good travel. It's got about a centimeter travel. And 2, it requires no electronics at all. It's the potentiometer that gets wired up. So it's a soldering job, not a programming job. So I just wanted to point out that this part to folks. It may be useful for other things. I have some ideas for joysticks that could use these tiny little slide pots. So there we go. This was a little long-winded, but I wanted to get that out there for people to play with. Thanks for watching.